In this video, we are going to solve some exercises about the indeterminate forms 0 over 0, infinity over infinity, and 0 times infinity. For the 0 over 0, if you remember, we were using the factorization methods. So for the, I'm not going to solve all three of them, but maybe I'm going to solve the A1 and the D1. For the A1, x minus 5 and x squared minus 25 I have. Firstly, I'm going to prove that it's equal to 0 over 0 infinity, indeterminate form, sorry. 5 squared is equal to 25, 25 minus 25, it's equal to 0 over 0 indeterminate form is going to be. So if it is 0 over 0 indeterminate form, the method that we are going to use is factorization, it should be. Then A is equal to limit x tends to 5, x minus 5 over x squared minus 25 is equal to x squared minus 25 is equal to limit x tends to 5. Here it is equal to x minus 5 is the same, but x squared minus 25 is going to be x squared minus 5 squared, it should be. That's equal to limit x tends to 5. X tends to 5, x minus 5 over x minus 5 times x plus 5 it must be, because a squared minus b squared is equal to a minus b times a plus b. And when you simplify this 2 here, 1 and 1 it's going to be, then the answer is going to be equal to limit x tends to 5, 1 over x plus 5 is going to be, that's equal to 1 over, here when you replace 5 plus 5, that's equal to 1 over 10 is going to be for the first one. Okay, I said the next one, it's going to be maybe the last one, D1 here. I'm going to solve the D1 here, and the others, they are going to be homework for you, and we will solve in the class these questions. Limit x tends to 1, 5x cube, 5 times x cube minus 1 over x minus 1 it's going to be. Here also we know that 1 cube is equal to 1, or 1 is equal to 1 cube again, right? And instead of 1, I'm going to write 1 cube. So this is a cube minus b cube. A cube minus b cube is equal to a minus b times a plus b. A squared plus ab plus b squared is going to be. So that's equal to the expression, the expression is going to be equal to limit x tends to 1, 5 times x minus 1, a minus b times a squared, x squared, a times b, x times 1 plus x plus 1 is going to be. Then what is written to down? It's going to be equal to x minus 1 here, and when you x minus 1 and x minus 1, when you simplify, it's going to be equal to limit x tends to 1, 5 times x squared plus x plus 1. That's equal to 5 times 1 squared plus 1 is going to be, and that's equal to 5 times 3, and it's equal to 15 is going to be. So the limit of expression is going to be 15, but we are going to, firstly we have to write, I didn't write that one, 5 times 1 cube minus 5 is 1 minus 1 is going to be equal to 5 minus 5, which is equal to 0 over 0 indeterminate form. I need to prove that one, then I need to solve question, but I know the answer, that's why I solve directly. Okay, the second part, if you remember, these are with the formulas, that's why I am going to apply directly formulas. Sin ax over bx is equal to limit x tends to 0, sin ax over bx, it was equal to a over b. So directly I'm applying the formula 5 over 7. Here the formula is it's same for the limit x tends to 0 ax over tangent bx. It should be equal to a over b, but here it's going to be equal to x. Here we have x minus 3. I didn't explain this one before, but for the b1, limit x tends to 3 x minus 3 over tangent 2 times x minus 3 we have here, and the formula x over tangent x or bx over tangent ax it should be. And here the value when x approach to 3 minus 3, this is going to be 0 with tangent 0 is going to be. This is the indeterminate form also for us. But we can use these substitutions also. X minus 3 is equal to t. Then when x tends to 3, t tends to 0 also is going to be. So the expression becomes limit x tends to, t tends to 0, x minus 3 t over tangent 2t, which is equal to 1 over 2 is going to be. It's same for this expression. Here x minus 2 is t, so 3 times x minus 2 it's going to be limit the c1. This was the c1 I'm solving now. Limit x tends to 2 sine 3 times x minus 2 over tangent x minus 2 it's going to be. If x minus 2 is equal to t, this expression is going to be equal to limit t tends to 0 sine 3t over tangent t it's going to be, and here the formulas a over b, so 3 over 1 which is equal to 3 is going to be. Okay, the last one is also d1 needs to trigonometric substitution, because we know that cosine 1 minus cosine 2x 1 minus cosine 2x over 2 is equal to sine square x, That's why here instead of 1 minus cosine 2x 1 minus cosine 2x in the root it is, I'm going to write 2 times sine square x, that's equal to 2 times absolute value of sine, root 2 times absolute value of sine x is going to be. So when you do this trigonometric substitution, limit x tends to 0, root 2 times, instead of root of 1 minus cosine 2x, I'm going to write absolute value of sine x over sine 2x, and when you apply the 0 here it's going to be non-negative, that's why not negative sine 0 it's going to be. So when it is not negative you can take directly, it's going to be equal to limit x tends to 0, the absolute value sine it's going to be positive root 2 times sine x over sine 2x is going to be. Okay, this 2 and root 2 we have here, so we are going to replace here, we are going to write like root 2 times a over b. A over b form, if you remember, I showed here sine ax over sine bx. Here this is 1 over the 1 here, 1 over, it's equal to 1 over 2 is going to be the answer. So the answer is root 2 over 2 it must be. For the infinity over infinity, if you remember the rules, n is greater than m, n is equal to m, and n is less than m cases there was. And this is a n x to the power of n, if you remember. A times x to the power of n over b times x to the power of m. If n is greater than m, the limit is equal to, if you remember, limit it was equal to 0. Limit it was equal to n is greater than m. Sorry, limit it was equal to infinity. N is equal to m. The result it was equal to a over b, and n is less than m. The result it was equal to 0. Here, and for the first one, when I check the powers, this is n, and this is m it's going to be, and as I see, n is equal to m. So when the powers are same, you are going to get the coefficients, which is equal to 3 over 1, and that's equal to 3. This is equal to n, and n is less than m. So n is less than m, the limit is equal to 0 is going to be. Here we have minus infinity squared, the answer is going to be plus, and minus infinity, so the answer is going to be minus now. Minus over plus, it's going to be minus. First I need to define the minus for the minus infinity. And here at x squared we have here, x squared is equal to this is n, and this is m, the power 1 here, and this is m, and this is the case n is bigger than m, so the answer is going to be infinity. But here it goes to minus infinity, and this is infinity squared, it's going to be positive, and this is going to be negative minus infinity, so the answer it should be minus infinity. Here when you get x squared parenthesis, we have to be careful about this one. This is x to the power of 5, and when you get out x to the power of 5 out, it should be like this. Limit x tends to minus infinity, x squared plus x plus 2 over 3 plus root of fifth root of x to the power of 5 plus, times 1 plus 1 over x to the power of 5. You remember from the solutions of this type of questions. So this is going to be 0, and this is x to the power of 5 it's going to be, and when this expression is tends to minus infinity, here the power is 5 also. That means that we are not going to take in absolute value. That's why it's going to be equal to limit x tends to infinity, x squared plus x plus 2 over 3 plus x also. So this 3 plus x, it's going to be the numerator here. There is numerator and denominator. The numerator's power is bigger than denominator's power. That's why it's going to answer is going to be infinity. But since it tends to minus infinity, the result is going to be minus infinity. Okay. Now 0 times infinity cases. These are tricky cases, and I'm going to solve only first one and the last one. The others, they are going to be homework for you, and we are going to solve them in the class. Here 0 times infinity case, this is as you see it was similar with the first question that I solved with 0 times infinity questions, and the A1 it's going to be limit x tends to infinity sine 6 over 7 times 1 over x. I separate the coefficient consciously, and x goes down. When it goes down, it's written as 1 over x. When this tends to infinity, when x tends to infinity, this is written like t, and t sine t 6 over 7 t over t, t tends to 0. And this is the case for the sine ax over bx. Then the coefficients are here 6 over 7 over 1, which is equal to 6 over 7 is going to be for the first case. Okay, the second one is here sine 2x. I'm going to solve the d1. The others, as I said, it's going to be homework for you. d1, here limit x tends to 0 from the positive side, but this is not exactly important. Sine 2x over cotangent 5x can be written as 1 over tangent 5x. And this is going to be times 1 over tangent 5x. And that's equal to limit x tends to 0 sine 2x over tangent 5x. This is the case sine x and sine ax, limit x tends to 0, sine ax over tangent bx is equal to a over b. It's going to be, so the answer is 2 over 5 is going to be only, I forgot here, limit x tends to 0, please.